Working in virology is important because of the impact that it has on, say, the health of others around the world.
What draws them to the course is an interest in infection, in the way in which disease works in the human body and how we can counteract that. So on this degree course, we have students from a wide variety of backgrounds, and they come from both the UK and overseas.
They were all from scientific backgrounds. It was quite nice to have a perspective from a different university, and you can really learn from each other.
The infection and immunity course is a specific set of modules of classes, basically, that they give you that cover subjects in infection and immunity and human disease.
We start off in the first semester by looking at the sorts of diseases that are caused by bacteria, by viruses, by parasites. And we also consider the immune systems and how your body fights infection. And then in the second semester, we try and look more at how we diagnose disease and how we treat disease.
You get to write things on cancer biology, different infectious diseases, malaria, things like that.
And then in the last part of the course, the bit which is still compulsory, but you have some choice, is when you do a research project. And obviously then you would select a project working with one of the research labs within this faculty.
So there will be projects which you have interest in. And also the projects are also quite good in terms of they have a broad range of techniques and principles.
Even just being like 3 weeks into the project, I can already tell that there's a huge amount of direction that you can apply to it that you can't with just a bachelor's. So that's been a really positive thing.
The most important thing that's changed over the last, say, 10 or 15 years is the amount of information that we have available and the speed in which we can generate that information about biological systems. People talk about big data. It's true, it's just mind-boggling the amount of information that's out there. And learning how to deal with that is part of the process.
You can tell that you're there to learn what's going on in the research world, what's actually happening, instead of just sort of following a curriculum.
I give some lectures on viruses, for example, like hepatitis C virus, which is one of the viruses that my lab research on. And I'll bring into those lectures information from what the guys in the lab are doing at the moment. And then, of course, when they do their research project, they come into a lab, they're working with the postdocs, with the PhD students, and they're doing a piece of original research, which we hope will lead to publications or increased knowledge about the field. So research-led teaching is implicit in the whole of the process.
It's a very good master's to prepare you for, say, working either within science, and the skill set that you develop could be also applied to jobs which aren't in science as well.
It's a springboard to the rest of your career, basically. And I think that's how a lot of people see it, and that's definitely what it was for me.
We're trying to tailor this not only to the ability of the students to work in research, but also to go into industry and to be competitive for those industry jobs.
Leeds has a very active research community with fantastic facilities.
We have new kit which is arriving all the time, which is state-of-the-art, and we are in fact envied by a lot of other universities in the UK for the facilities we have for biological sciences.
Every day is different. You guide your own experiments and you try do hypothesis-driven research to study towards a bigger goal.
This sense of independence that I've been able to develop while I'm working in the lab has been really, really valuable. And that's something that I think will come across in research that I do in the future.
It prepares you for the next level, and I believe that doing research could hopefully help make a difference.